I Yeah, I don't look at the number of views that I have. It's very distracting, so it doesn't really matter to me. If you want to watch, can do something like whatever you want. That is, you can choose between I say nothing and I just work, or I think out loud, or I even explain what I do. But my experience is that as soon as I start explaining what I'm doing, then people leave. Well, I'm trying to write a program that will give me insight in how to give mate with a rook. It's mostly fun because I already know how to do that on a normal chessboard. But this takes place on an infinite or a quarter infinite board. Because there is only one corner. And there are some interesting things. Like, for example, initially, white here has the rook. So a white king and a white rook. And the black just has a black king, right? And initially I thought if the white king is in the neighborhood of the corner and the black king is further away from the corner, then you cannot give mate. It just walks away in the infinity. But later I thought that actually not true. I think you can always give mate. So that's something I expect to pop up on a reasonably large board. That you can see that it will cut off the black king with the rook and then move diagonally with the white king, while the black king, once it runs into the rook line, can only walk straight along that line. So it's kind of, if you have the distance to the real edges, I have my corner is in the top left, so I have an edge on the left and an edge on the top. And then say the distance to the left edge plus the distance to the top edge, that sum increases with 2 for the white king, because they can always walk diagonally away from the corner. But if you cut off the black if you cut off the black king, then with the rook, then it can only walk straight. So what you can do is you can make the sum of the x and y distance of the white king arbitrarily much larger than that of the black king, and then you use that to just gain an enormous distance in one direction, and then you switch the rook to the other direction, and then you will be able to come in front of or behind, or whatever you want to call it, with the white king. And then you can start giving mate, working towards the corner. Initially I wanted to know just what the most optimal way is to give mate. I mean, it's like if you are, say, very far away from the corner, but you are very close to an edge, then it's just, I mean, if the black king only has one line to walk, it can only walk along the edge because the rook is cutting off the second row already. Then it takes about the distance to the edge to give mate, right? I mean, the black king cannot do anything else and just walk to the corner. While if you are on the diagonal, it's going to take way more moves. So there must be some optimal thing. I mean, either you can try to drive the king to the edge, but then it goes faster, or you can drive it along the diagonal, but that goes as fast, except that in that case you also have to move the rook. So I think along the diagonal is like twice as slow as along the edge. I don't know, I just can't really get my finger behind it, so I wanted to write this program to understand it. This class here contains the child position, so this is a part of a board node. And then if you do a legal move, you get on one of these boards. And these are the boards that can reach this board by doing a move. So you can go from parent to the current one to that one. So making a whole graph. And I realize now that there is a big difference between who is to move. So I wanted to split this class up from being called data to having two of them. And that then, of course, will require a lot of changes, because now everywhere where I use data and everywhere where I use a node type, nodes type, I suddenly have to use one of these two and one of these two. But I think that the compiler will just tell me everywhere. It just stops compiling and then I'll fix one by one and it should work again. But first I have to get these two classes correct. I think I did this one now, right? I mean, this is the same as that one. It's the constructor, and then both child and parent have a different color to move. So these contain BlackToMove positions. The only point where this is also child, it's also black. The only point where white turns up is here, because that is the current board. And succeeding board is actually a child position. Maybe should change the name. It's not my habit to use two different words for the same thing. So now I'm using board, while it's an iterated to map with boards, so it's kind of a board. A position is derived from board and then has a little bit extra information. But position is the class position, at least. Position itself is, of course, also a chess position. And if you know who's to move, then a board plus that knowledge is a position. Which means that if I know the board and I know who is to move by the fact that the type tells me who is to move, then I can call it a position in the comments. All very confusing sometimes. Okay, so I have now this one. I still have to change this. So just a copy of the BlackToMoveData.cxx. But this one must be white, so I have to swap black and white. 1, 2, 3, 4, 5, 6, 7, 8. So rename black to blue. Nothing. 1, 2, 3, 4, 5, 6, 7, 8. And then white to black. 1, 2. I should have done that earlier. This can't be good. Damn it. Still have to do this one, no? It's basically 3. Percentage shifters. Got over that one. White, black, yeah. Turn now white to black with capitals. And then the good to white with capitals. This one. Now it should be swapped. So yeah, current board is again white. And the same color as the class itself. This one is black. Nothing good. Would have been faster if I just changed it by hand, it seems. Okay, I think I did these now to I renamed these and added those, but yeah, not much difference. So let's change the CMake file. BlackToMoveData and WhiteToMoveData. And then let the errors begin. Where's my error? Data.h not found. Oh yeah. Duh. Yeah, this is going to need both of them, I bet. BlackToMove and WhiteToMove. BlackToMove. I already copied it. We don't have a data, but now my both datas have the same type. Can't use either, I guess. I'll switch those to them. Stores iterators to positions that are made in a given number of ply. So it depends on the number of ply which type this is. So I'll have to split these up then as well. Let's see whether they are used. This is just used, well actually here as well, but it's just an accessor. Or that's for the made in ply. Yeah. I'm afraid I have to split up a lot of stuff. Let's black to move it's even. Maybe we should have made it a template or something. Pass the black or white as a template. It's a bit messy somehow. Yeah, in principle it's just exact same as before, with either black to move in front of it or white to move in front of it. It's not that much different, right? Parent positions is private member of WhiteToMoveData. Yeah. Am I adding something to it? Yeah. No, just find it. But here you're adding something to it. So it's not even const. Let's just make it a friend. Kind of need access to these things from that. In the other way around. To move data. We can no longer do that. There are now different types. Ugh. So we can't have a color to move. Really have to split it up. Ah, that's just stupid. Sorry, I didn't see your question. Well, you said I won't leave, but Joe can go any minute. After my explanation, I have to give you that. If you're still there, then I'll answer your question. Notice a type. What to do. Since there are really different types now, I really have to generate. Well, yeah, well, it's going to be different code, I think. It shouldn't have to be though. In the end, the assembly is the same. But yeah, different types, different code. But it could still do just two calls to template functions. And then just pass the color as a template argument. Let me try that. So assume this is a template where the color yeah, I would have to use color type then. Kind of lame, but color type must be integral type, and I think enum works, I hope. So then we are, when this is being called, I don't think I can overload it for being a template and not being a template. So let's rename this thing. So now you already have the column, but at least now it's const expression. Can create a column. No, it is already a color type. So now can have different types, although I can't really type it here, but we can use auto. What do you do here? I'm kind of a little bit of a mess with it, I have to admit. At any rate, we need another function. So this calls the template function that I'm running. Template function must be in the header. Let's begin with moving it. Let's put it down here. Okay, so I need this, which is a template that returns a different type as function of the template parameter. That can only be achieved with an specialization. To be honest, I'm not sure if you can specialize a function, a member function. Somehow I think that you cannot. Maybe I should just try. If it cannot be done, then I'll do it in a different way. Nah, you can't. I wouldn't even know how to code it. I'm still going to try, but so it is just a not even defined member function, which is a template member function. It has to return something. Oh boy, I have to use auto here because you don't know what that is. It has to be online anyway. Let's do it like that. And then I can do if const expression color equals black. Return this one. Else return that one. Well, it might even work. Might even work. Now this is not a specialization, so but if the return type still changes as a function of which branch it picks, then it's kind of a specialization. But not really, I don't know. This should work. It should compile. And then here this type, well, this must be the iterator type of the map. So maybe you should just get the type from, well, it's auto, you don't know what it is. Or you can get the type with declaration type. Declaration type. Declaration type of to move map iterator. And here again, declaration type. That's the other to move map. Let's see what this gives us. If it compiles, it works, and otherwise we'll have to fix more. Right. Oh, I didn't specify that one yet. Yeah, I need an cons expression opposite for the color. It looks like a free function. Maybe we can even make that can I make that a member function of to move? Already exists even. So I have a to move, which is a cons expression. That's important, of course. And color, and then call the member function opponent on that. So opponent is indeed a member function of color, and color can be constructed as a cons expression, but this thing is not a cons expression. So I have to add that as cons expression. Now that should work. I wouldn't know why not. Notice card attribute cannot apply to type, so it thinks I'm applying it to a type. Interesting. Maybe it has to go here. Missing type name prior to dependent name. Yeah, this is a template. So this is the template argument. And that is influencing this type. And then the compiler says, I give up. So I have to tell it that the declaration, what? It is already a type. No, it's not. Sorry, I'm doing it wrong. It doesn't know that iterator is a type by this point. So you have to tell it that this thing here is a type. Because it can't know that without instantiating the template with a given color. But the syntax is already checked before it does that. So it just encounters this source code and then it does a certain kind of checking. For that it needs to know that this is a template, and then afterwards it instantiates it. And then it turns out to actually be a type. Yay! But okay, it needs to know that before, I guess. Unknown data. Oh yeah, right. But we can definitely use auto here. Because, well, that type is known then, right? So other stuff that I need to auto. I don't think so. Ooh, there's no nodes type. No, that's true. Oh, this is a main. Already made. Yeah, that would be BlackToMove then. Which means that current position must be a BlackToMove iterator. Which means that color to move map must be... Oh, bloody hell, we're also running with both colors here. Oh, this has nothing to do with already made. Well, actually it does, but only if it is made, which will only be the case for BlackToMove. But it also runs over all the positions where it just is a check or a draw. Afraid I really have to unwrap this thing in two pieces. Okay, color is only used there. To move is black here, which means that this is simply that, which means that this is black to move nodes. Black to move map. Now this is the first one. It's 0 here, I agree. But yeah, plus? Nah. I'm just gonna assign it here. With white to move it cannot be checked. It would be illegal. With white to move it cannot be made. Or still made. Does it compile yet? Long time data. think ether changes type. Later on I'm trying to assign ether to a child position, then it changes type. I'm just gonna comment all this out, just not code it anymore. No matching member function called to map with to move. What? In instantiation of function template specialization, graph generate edges with color black. Requested here. Candidate template ignored. Invalid explicitly specified argument for template parameter color. Is it calling this invalid or what? Yeah, there must be a color type. I think component is not returning a color type. No, it's returning a color. This structure can just call color. Declaration type color to move map, aka map board BlackToMoveData distance compare reference cannot be used prior to double to scope operator, or that was called, because it has no members. I have to remove the reference, I think. I just don't know the exact syntax. It's something like, I don't know, remove ref or remove CV or something. Just strip it down until you can use the double colon on the type. So, standard remove reference. Yeah, so it is only removing the reference. Yeah, let's just look at this and then maybe well, the others are also mentioned there. Yes, reference, remove CV ref. Maybe DK. Okay, I'll go for the other option then, what it said. You can just cut the declaration type of this. I mean, why not? Yeah, it feels a bit lame, but it's actually pretty good. And then of course without the iterator part. Oh fuck me, I can just use auto. What? Of course I can just use auto. It's even better. It compiles. But does it print the right numbers? That is the question. It printed the right numbers. Amazing. Blip, 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 blip. Yep. Now then I guess everything works. And these are all the mate positions. Also still works. Well, made in one. I mean. But why did I need that again? So this one is for this runs over all positions that are made in 0ply. And then does that. And I can do that if I replace this 0 with well, whatever ply it is, and that ply plus 1. And this is correct for all the BlackToMove positions, I think. Well, actually, this is correct anyway. It should already have that ply by the time I can run over it. But having done this, I can run over all positions that have ply set to 1. Either by running over all positions, which is too slow, and then checking if the ply is 1, or accumulating all the positions that get ply equals 1 set, and then run over that immediately. So I kind of want to collect all the positions that are marked with ply is 1. Can we not let's do that in here? Maybe pass a vector that it appends to. I guess this never happens, right? It should never happen. Otherwise I have a slight problem there, maybe, or not. Looks like I would have a problem. Why did I say that it was not possible? Because we get here only for a slowly incrementing max ply. And ply can only be set from max ply. So this can only be smaller than the current max ply, smaller or equal. Yeah, that seems to work, right? Just also again all the made in one line thing, so it accumulated it correctly. The only thing I'm missing was there's only two positions, I guess. The blacking in the corner and the white not opposite. Yeah, here. It's actually more than two. A lot more. Yeah, never mind. A lot. Okay, anyway, yes, we have all of them, I suppose, and then so now I can run over all. I say I can set apply to 0. I have to start with this already made. So here I'm going to set apply to 1. I'm going to call this parents. Because apply is odd here, it is WhiteToMove. And then we're going to make a loop. So the parent should always be WhiteToMove. Well, let's put it in the name, although it's already in the type. And then instead of printing them, we're going to do, you do a trick. In the end, this must be a for loop. And we do this while this is not empty. Because in that case, we definitely have to do this loop. Apply is gonna be incremented with 2 every time, although probably will increment it already halfway. It's maybe still better to do this outside, actually. I don't know. Nah, let's do it outside. So I'm just setting apply here, and then we make this a while. And then I can increment ply here and then do something and then increment it again. That should already be the case. So we find all the BlackToMove parents that are that is made in ply, where ply is even, and then you run over all those positions. And then set the maximum ply of the parents to ply +1. Because if with WhiteToMove we have a move such that it is made in ply, then of course we're going to do that move. And the current position is then ply +1. To be implemented, this stuff here. But I think I'm going to keep that till tomorrow. Let's go to bed. Yep, good night.